Hi guys, it's Miss Journey,
and Miss Layla.
and today we're going to be doing problems on increasing and decreasing behavior.
Number 1, find the intervals where the function f of x is increasing or decreasing. Also find any local maxima or minima. First, you would find the derivative of f of x, which is 2x minus 4. Then you would try to find the critical points in which you would set the derivative equal to 0. Two x minus 4 equals 0 gives you x equals 2. Then you would have to test above and below the critical point to find where the function is decreasing or increasing. For test points, we used 0 and 3. You would plug the test points into the derivative. The derivative of f of 0 equals negative 4. Since it's negative, it means it's decreasing at this point. The derivative of f at 3 would give you 2, and 2 is positive, so it will be increasing at this point. When you draw it, it would be decreasing and then increasing, so x equals 2 has to be at a minimum. So you would test for the minimum by putting 2 for x in the So you would test by putting 2 into the regular equation. In doing so, you get 1. Which would be the local minimum for f of x.
We're going to try that again.
Negative 1 for the local minimum. Then finally, you would state the intervals for which f of x increases and decreases. So f of x decreases from negative infinity to 2, and f of x increases from 2 to positive infinity, with 2 as the local minimum.
Okay, question number 2. Determine the intervals on which the function g of x is increasing or decreasing and find any local extrema. So once again, we're going to take g of x and find the derivative. So using the exponent rule, we get 3x squared plus 12x. Then, to find the critical points, we're going to set the derivative of g of x equal to 0. Using greatest common factor, you can factor out 3x, and in the parentheses, we'll have left x minus 4. Finally, the equation gives you x equals 0 and x equals 4 as our critical points. Next, we're going to find testing points. So, for our test points, we are going to use x. For x is less than 0, we're going to use we're going to use -1 as our test point for x is less than 0. One in between 0 and 4, which is x equals 2. And then one more test point greater than 4, which is x equals 5. Using these test points, we're going to plug each of them into the derivative of g of x to figure out whether the graph is increasing or decreasing. So g derivative of -1 gives you 15, which is positive, so that means that the function is increasing. Now we plug in g derivative of 2 and solve. When you plug in 2, you will get -12, which means that the function is decreasing, as 12 is a negative number. And finally, we're going to plug in x equals 5 in the derivative of g of x, which gives you 15, again, which is also positive. Therefore, the graph is increasing. So if you were to draw that on a line, you'd have the function increasing from around 0, increasing by x equals -1, decreasing for x equals 2, and increasing once again at x equals 5. So it is positive from -1 to 0. It's increasing from -1 to 0, decreasing from 0 to 4, and then increasing once again from 4 to 5. And finally, to find any local extrema, we're going to use our original critical points, 0 and 4, and plug them into our original equation. Because the graph is going from negative to positive at x equals 0. That means that there is a local maximum. And then because the graph is going from positive to negative at x equals 4, that means that there is a local minimum. Oh my gosh, I messed up the whole thing. I erased the whole thing and retake. There is a local max at x equals 0 because the graph is going from positive to negative slope-wise. And there's a local minimum at x equals 4 because the graph is going from negative to a positive slope. Okay, finally, to find these values, we're going to plug 0 and 4 into the original equation. G of x equals x cubed minus 6x squared plus 5 to find the values of the maximum and minimums at x equals 0 and x equals 4. So the max at x equals 0 is 5. And then when you plug in 4 into g of x, you get negative 7, which means that is the minimum value of the graph of g of x. So finally, you can say g of x is increasing on the intervals negative infinity to 0, as well as 4 to infinity, which means g of x is also decreasing on the interval 0 to 4.
For question 3, for the function
Where the function?
g of x, find the intervals of increasing and decreasing and identify the local maximum or minimum. So first, you take the original function and you find the derivative of it. The derivative of g of x is 3x squared minus 6x. Then you set the derivative equal to 0 to find the critical point. When you set the derivative equal to 0, x equals 0 and x equals 2. Then you have to test below and above both of the critical points to see where it's increasing and decreasing. So we're going to test -1, 1, and 3. So the derivative of -1 equals 9, which means it's positive, which means it's increasing. So again, the derivative of -1, which what we're testing, equals 9. And that means it's positive, and which means it's increasing at this point. Then we'll test the derivative of 1, which equals -3, which means it's negative, which means it's decreasing at this point. Then finally, we'll test the derivative of 3, which equals 3, which means it's positive and increasing at this point. So the interval for increasing is -infinity to 0 and 2 to positive infinity. And the interval for decreasing would be 0 to 2. So it would go from increasing to decreasing to increasing again, which means that the maximum would be at 0. So you put 0 into the original equation, and when you put 0 into the original equation, you get x equals 0. And for the minimum, you would put 2 into the original equation. So the max would equal 4. And for the minimum, you would put 2 into the original equation. So the minimum is at x equals 2, and the minimum would be 0. And that's it.
Okay, so for question number 4, consider the function f of x and determine the intervals where the function is increasing and decreasing, as well as finding the maximum value. So once again, the first step is to use the original function. Oh, there's a typo. So the original function would actually be -2x squared plus 4x plus 1. Using the original function, we're going to find the derivative of f of x, which would then be equal to -4x then for the derivative, it would be -4x plus 8. Now to find the critical points, we will set derivative of x equal to 0. Minus 4 on both sides, -4x is equal to -4. Divide both sides by 4, and you will get x equals 1. So now to figure out whether the graph is increasing or decreasing on an interval, we have to test points outside of x equals 1. Our first test point is going to be 0 because it is less than 1. And our second test point is going to be 2 because it is greater than 1. Then you take the points 0 and plug it into the derivative of f of x, which will give you negative 4 times 0 plus 4, which equals 4. Because this number is 4 and positive, that means that the graph of x is increasing at x equals 4. Or at x equals 0, sorry. Next, we plug 2 into the derivative of f of x, which will give you negative 4 times 2 plus 4, which ends up being negative 4. And because this number is negative, that means that the graph of f of x is decreasing on this interval. Finally, to find, the graph is increasing from negative infinity to 1, and it is decreasing on the interval 1 to infinity. Finally, we need to find the maximum value. To find the maximum value, we plug the critical point 1 into f of x, which will give you negative 2 times 1 plus 4 times 1 plus 1, meaning f of x is equal to 3. 3 being the maximum value of the graph of f of x. Three being the maximum value of f of x. This is because at x equals 1, f of x is going from a positive slope. F derivative of x is going from a positive slope to a negative slope, meaning that there will be a maximum.
So for question 5, consider the function f of x. Find the intervals on which f is increasing or decreasing. Find the local maximum or minimum and minimum values of f. So first, you have to find the derivative of f of x. And the derivative should give you 3x squared minus 12x plus 9. Then you would set the derivative equal to 0 to find critical points. When you set the equation equal to 0, you get x equals 1 and x equals 3, which are your critical points. Then you have test points above and below 1 and 3 to see where they increase or decrease, where f of x increase or decrease. So we would use 0, 2, and 4. 4. When you put 0 into the derivative equation, you get 9, which is positive and increasing. Then when you put 2 in for the derivative, you would get negative 3. Yeah, negative 3. Which is negative and decreasing. And for the last one, when you put 4 in for the derivative, you would get nine, which is positive and increasing. So f of x would increase from negative infinity to 1 and 3 to positive infinity. And f of x would decrease from 1 to 3. Then you would plug in 1 and 3 into the original equation to find local maximum and minimum values for f. So f of 1 would give you five, which is a maximum. Because the graph would go from positive to negative, which is increasing to decreasing, which gives you a max. And when you put in f of 3, you get 1, which is a minimum because the graph changes from negative to positive, which is decreasing to increasing. And that is it. Thanks for watching.